G'day guys, I'm going to contribute a little bit to the trigonometry that you've all been doing, and that's by going through the that 2016 trigonometry problem. So I've just sketched out like the bare minimum that I need. So I've got the flags up at this point, I've got the Sky Tower here, and I've got Devonport over here. I'm just calling it D. So we know Devonport is at a bearing of 0.59 from the Sky Tower, and we know that the flags are at a bearing of 322 degrees from the Sky Tower. So the Sky Tower is our point of reference. Now the first thing you want to do when you're doing one of these problems is I don't know if it's a word, but we're going to what we call rectangularize. So we know north is perpendicular to this line here, right? This piece of paper. So what I do is I get my ruler and I make it parallel, make these measurements on it parallel with the edge of the page, and then I just go straight across here like that. I'll try and get roughly in line. Same thing here. I just go parallel with that piece of that paper, and I go through that point. That's going straight up through there, and same thing through this point. That's going across here like that, and I can just go straight down from this point. So I've constructed a big rectangle. Now, what I want to know is, maybe I'll use a blue pen for this. I want to know, take this blue line, I want to figure out this angle here, don't I? Okay, so if I want that angle there, let's call it theta, then I need to know this side and this side. So to calculate that side, I need to put in the things that I do know. So I know that Devonport is at a bearing of 5.9 from the Sky Tower. So that means that if that was north, straight up, that's at an angle of 5.9. So what I'm going to do is I'm going to take 5.9 away from 90. So that's actually, I'll probably draw this a bit small, that's 31 degrees in there. And I know that the flags are a bearing of 322 from the Sky Tower. So again, if I went all the way around like that, that would be 322. Well, I know that going all the way around to that line is 270. So let's go 322 minus 270, 52. So we now know that that is 52 degrees. So I'm going to find this side by using trig. I'm going to find this side using trig, and I can subtract them, and I'll have this side C. And it will then I'll need these two sides, so that I have this entire length. So let's call that D and E. So calculating A. Well, A is O over H, so that's going to be 2.45 sine of 52, because that's the opposite over hypotenuse. That gives me sine at that angle. So if I times by the hypotenuse, I should be pretty comfortable doing that now. Then that is my working for A. B, well, that's going to be O over H as well, so that's 354 for that line there. So that's going to be 3.54 O over H, so sine again, sine of 31, and I've just put that in the wrong place, haven't I? 3.54 sine of 31, and C is going to be the difference between them. So let's just do that on a calculator. 2.45 sine 52. What's that? 1.93. B is 3.54 sine of 31, and B is 1.82. C is actually going to be A minus B. So I get 1.93 minus that. C is 0. I'm going to go 11. So C is 0.11, And now I just need these two lengths. So let's go D. We want to find D. Well, this length here is A over H. So it's 2.45 cosine, because we're using adjacent or hypotenuse, 52. And E is A over H as well. So that's 3.54, the hypotenuse times cosine of the angle. So 2.45 cosine 52, 1.51, and 3.54 cosine 31 is 3.03. Great. If we add those together, we'll have this side F. So F is E plus D. So let's go 3.03 plus 1.51. So F is 4.54 kilometers. I'm just going to write that one on here. 4.54. C was 0.11. Now we can find that angle. So we've got two sides of a right angle triangle. We can find that angle. So theta, what are we dealing with? O and A? Well, it's just going to be tan inverse of the opposite over the adjacent. 0.11 over 4.54. And that's going to be, what's that? 0.11 divided by 4.54. 1.4. Well, that's not the answer, is it? We'll calculate the bearing from the flags to Devonport. So if that was north, we just have to add 90 to that angle, don't we? So bearing is 0.91 degrees, 0.914, right? Round to the nearest degree has a bearing of 0.91. Excellent. And you could easily calculate the distance as well, right? Using just Pythagoras. Hopefully that makes sense. I'll break it down again. So we just calculated A using this triangle because we knew that length and the angle. So that was A. We then calculate B, O and H. So it's sine again, calculated B. We then calculate C. Well, C's, because this is all right angles, right? We rectangularized the whole problem. We just took it away. So we got C. And then D was exactly the same as just a right angle trig. D and E was just using cosine though. And then we got F, because we just added those two. And now we're dealing with this triangle here, and we found that angle. Added it to 90, because we wanted to have the bearing from north all the way around. Hopefully that makes sense. It was pretty quick, but I'm pretty sure most of you got it right anyway. Nice.